So let's talk about how the CI bus actually works. Each of the devices is a block in the system. So block 1, this is a product. It could be a MSI, it could be a headset interface, it could be an operator desk console, but it is one of the products on the bus. Block 2 is another product, block 3, block 4, etc. What happens in here is each one performs its independent task, whatever that might be. It then shares that information through its output on down the line to the next unit. Each unit brings it in, does whatever its box wants to do with that signal, sums it back up, and sends it both directions down the bus to the previous and the next block on the bus. If you don't want a signal sent out, what comes in can be sent out to this local. Let's say this was a headset. I could take the output of the operator console and send it to my headsets, or with jumpers, I might not want it. Maybe I don't want to hear the headsets. They want to hear each other, but I don't want to hear them. There'd be a jumper right here to disconnect it so it doesn't come out of my speaker or my headset. My output, likewise, can be selected as to what is sent out to the rest of the network. There's jumpers in these lines that allow me to selectively send either upstream or downstream to the rest of the bus what's coming out of my block. The way this is accomplished is with line level 0 dB signals. In other words, this is like a summed broadcast network. We can send this stuff out to other products because it's all standard broadcast level. If you want to share this with a teleconferencing system, no problem. Just take the bus and send whatever you want out to that teleconferencing system. If you want to bring stuff in from the outside world, it's a line level signal coming in. You can send it, route it however you want because it's standard broadcast signaling. But it's bidirectional. So you've got a signal going from left to right and a signal going from right to left. Talk and listen. All of it's simultaneous. Why ALC, or automatic level control? First of all, we control the level coming out of each microphone so we can hear from a whisper to a shout, and all of it comes out at 0 dB. What we do is we basically open up the microphone gain as wide as we can get it so that every signal is always into limiting. What that means is that anything down here is turned up and anything that gets too loud is turned down using a voltage controlled amplifier. So it's not sharp, it's not cutting things off and missing words, it's not ducking, it's actually turning the signal down, which means you get a very consistent signal output from every microphone in the system, and the technician, the setup is so simple. There's very little to do. Basically, all he's got to do is turn it up till it sounds good. The connectivity is, again, very simple. You take the operator desk console, which is always a master out. We assume that the operator is never a slave. They are always the master. They're the controlling body. They connect to the next device, which in this case is a CI MSI. So a master output goes into a slave input, and that's all your technician has to know. He's done. He connects his microphone, he connects his speaker, he can adjust levels on the front of the unit, but there's nothing else he has to do. The way the patch cables work, your first pair in a Cat6 patch cable is used for a call switch. This is where anyone on the bus might have a foot switch and need to signal each other. In other words, the doctor's in the operating room and his observation operator console is in a lab environment. The lab technician is off doing a biopsy or something. The doctor needs to get the lab tech's attention. He stomps on a foot switch. It sounds a tone over the operator loudspeaker. It can sound a tone over speakers in the ceiling, but it's a signaling system to let people know they are needed at a remote location. Conversely, on the bottom, on pairs 7 and 8, we have an alert signal. Now what this is it's different. This is the operator pushing their button taking control of the system. Think of it as a priority or chairman override. So for instance, the doc's in there rocking out doing an operation and they are listening to music. They want to have a conversation with the doctor. They have to duck the music. They don't want the music coming through the intercom call and shouting over the music. That's where this comes in. This alert pair tells the music to shut down while we're having a conversation. Then your audio, your master out is on your pair 4 and 5, and your master in is on 3 and 6. If you know how EIA 568 Cat5 patch cables are wired, this is a pair, and 3 and 6 is a pair, this is a pair, and this is a pair. For noise cancellation, we did it this way so that we get total noise immunity and no feedback. The master output, if you look at it this way, the master output is connected to the slave input. The slave output is hooked to the master input, and that's how we get bidirectional communication. If for some reason you need 2 inputs and you don't need an output, you can use a master output as a slave input. What you have to do is build a custom Cat5 cable that crosses these pairs over. That's all you got to do. Swap those pairs, an input can become an output. The system doesn't know the difference. It's set up to be convenient for your technician. Let's talk about some applications. In a typical cath lab application, you would have a hanging microphone, our little MJ1 mic jack on the ceiling with a Pro 45 dangling down over the procedure table, a ceiling speaker in the ceiling. Those wires home run to your MSI, which is mounted underneath the counter in the observation room. You have your slave input connected to your master output of your operator desk console, and you have a power cord sending the power up to the operator desk console. Your power supply is mounted on the wall and plugged into the nearest electrical outlet, and if there's a headset option, it simply plugs into the side of the operator desk console. It's literally that simple. The adjustments, if you take this thing out of the box, it will work without a single adjustment. The reason the adjustment's there is to accommodate special problems. There may be acoustic issues. Typically these procedure room, clean room environments can have very challenging acoustics, very hard surfaces. Therefore, inside of the MSI, there's equalization. There's 2 forms. There's a high roll, there's a low roll off. Those are to get rid of basic high frequency anomalies in the room, but there's also notch filters built into the MSI so that if there is a coupling between speaker and microphone that's relative to a dimension of the room, there are 2 notch filters, a high notch filter and a low notch filter built in here that allows you to take those frequencies and reduce them by up to 18 dB, so you eliminate the first 2 primary ring modes in the procedure room. A cath lab with a secondary observation speaker. Remember I said there are times when you need another ceiling speaker. This little speaker in the operator desk console isn't enough? Well, no problem. You simply add one of those little peel and stick amplifiers and another speaker. Now you can cover a very large room. The operator still has their local speaker, but they don't need to. Let's say this is a lab environment and they're not always sitting at the counter. They're off over doing some kind of a biopsy. They need ceiling speakers out here in this area, and they might be wearing a headset. This ceiling speaker is telling them what's going on over here. It could have a foot switch over here that the doctor signals and it goes dee-dee-dee-dee. When they activate the headset, it can automatically take control of the system. It can automatically turn this down. It can automatically turn this down. All of the control resides in the headset, so the operator does not have to be tied to that console. Let's say you've got background music. You have a second set of music-only speakers. They are typically positioned around the perimeter of the room. Now let's talk about why that is. You typically don't want the music right over the procedure room table. It interferes with the doctor's conversation. It also can be irritating. We use it as a background music in the outer perimeter of the OR suite. Those are hooked back to the output of the PA402 music amplifier. In this case, we have an iPod base plugged into the little tiny jack music input on the PA402, and then you have your control cable, Cat6, going from the PA bus output on the MSI over to the PA bus input on the PA401. Whenever the operator goes active, whether that were with a headset or with the talk button, this signal automatically comes over here and ducks the music. So the music automatically turns off. These microphones, in this case, we're showing a Pro 42 boundary microphone mounted on a boom arm underneath a monitor, plugged into a wall jack, again, over here running into your MSI. The MSI has built-in phantom power. If I failed to mention that, it's got built-in phantom power, so everything you need for most microphones. I can tell you that Sennheiser and Crowns require 48 volts, some of them, and that we cannot accommodate. We accommodate 24 volt DC phantom power. Again, you share a power supply, common power supply. All of this equipment is mounted underneath the counter, so it's out of the way, not taking up any desk space. And with power patch cables, you patch the power from one box to the next and onto the operator console. Cath lab with headsets. In this case, you've got one headset plugged into the operator desk console, but then they wanted a couple more over here in the operating room. So we put the charging bases in the operating room because this sometimes is lead shielded and you need to get those receiving units inside of that operating room. You simply take headset cables over to your headset interface. In this case, the customer mounted them in a rack. So you had your headset interface combiner in the rack. You had your microphone speaker interface in the rack. Then you had speaker and microphone cables going out. In this case, there was a shotgun microphone on the wall and a ceiling speaker over the table for the doctor to listen. These headsets, this particular customer I remember specifically, we got this all installed and they called me from the field and they said, we have a problem. The headsets in the OR are not coming out of the operating room speaker, so the doctor can't hear these people over in the corners wearing these headsets. The doc wasn't wearing a headset. The doc was talking over the microphone speaker and his technicians off in the corners were using the headsets and he couldn't hear them talking. No problem. That is simply going over here into the MSI, moving one jumper, and boom, the sound came out of this speaker just perfect and everybody was totally happy. So a lot of flexibility built into this product. What if you want a cath lab with headsets and music? No problem. In this case, they wanted the music in the observation room as well as in the procedure room, so that's just a common sound system. Then you have your intercom speaker and your boundary microphone connected to the MSI-22. Your Cat6 patch cable runs over here to the headset interface. The headset interface in this case was supporting 4 headsets, 2 in the observation area and 2 in the procedure room. You had your iPod base controlling your music, and your operator had total control through either a headset or a desk console. In a simple observation room, this was actually a sleep analysis center that we did. We had a hidden microphone on the wall near the head of the bed. We had a speaker so the operator could talk to the person that was doing the study. These were simply hooked to an MSI, and the observation controller had a observation or an operator desk console that they could talk to the patient in the sleep study center. The other thing I failed to mention is in some of these where you're doing something like a study or a sleep analysis, they want to record this. That is absolutely no problem because, again, it's line level. You simply come out of either the PA output if it's not used or the CI bus output, and either one of those gives you a line level feed that you can select what comes out of that line level feed, again, with the jumpers inside the MSI-22.
Lots of other tools to help you. We are available online 24/7, 365 at techworks-usa.com. There you'll find brochures, architects and engineers specifications. We're always here to do design and quoting assistance. We're also here for technical assistance, but as I've said repeatedly, it is always best to send us an email. Before you pick up the phone and call us, detail out what you need. That goes for field technical questions. Tell us what product you're in the field trying to work on. If you're doing design, tell us what project you're working on. Send us an email with plans and specs and scope of work and all the information you can share with us. If you have a takeoff, supply us a takeoff of the parts and pieces that you think you need. That way we can get back to you. And always take the technical training and read the installation manual. That will help you whether you're out in the field or if this is a design that you need some help with. But we're here. We're always here to help. Love hearing from you. Drop us a line. That about does it for TechWorks Collaborative Intercom training. Thank you so much for joining us. Take the test and get certified. Thank you.